Okay. Aniket, can you tell me which topic we discussed in last lecture? Newton's law of viscosity and types of the density and viscosity. Okay. What is the Newton's law of viscosity? What is the relation Newton's law of viscosity? Lalit.
Tau is equals to u du by dy.
Tau is equal to mu into du by dy.
Du by dy.
Mu into du by dy. What is mean by tau? What is the meaning of tau?
Shear stress.
Shear stress.
Shear stress, correct. And what is the meaning of mu?
Viscosity.
Viscosity. Which viscosity?
Dynamic
viscosity.
Dynamic viscosity, correct. What is mean by du?
Change in velocity.
Change in velocity, correct. What is mean by dy?
Change in distance.
Okay. And the combined ratio du by dy, it's called as combined ratio du by dy.
Velocity distribution.
Velocity distribution. What is another name for that?
Velocity gradient.
Velocity gradient, correct. And what is the correlation between dynamic viscosity and kinematic viscosity? Can anybody tell me what is the correlation between kinematic viscosity and dynamic viscosity?
Kinematic viscosity equals to dynamic viscosity upon density.
Okay. Drushti, can you tell me the mathematical equation in terms of the notation form?
V is equal to mu upon P.
Okay. That is not a V. The meaning is pronunciation is different. What is meaning of that V? Kinematic viscosity. What is pronunciation?
Nu.
Nu. Okay. That is not the V. That is a nu, and that nu is equal to mu upon rho. Mu is which viscosity? Mu is which viscosity?
Dynamic viscosity.
Dynamic viscosity. And nu means which viscosity? Nu.
Kinematic
Viscosity. And rho is density. Okay. What is the unit of dynamic viscosity?
Pascal second.
Pascal second. Okay. What is a conversion Pascal to Newton per meter square?
Newton second per meter square.
No. Conversion of Pascal, Newton and meter square. Conversion.
1 Pascal is equal to 1 Newton per meter square.
Correct. 1 Pascal is equal to 1 Newton per meter square. Okay. And there is one unit conversion. Again, we required the Poise. Poise is also unit of which viscosity?
Dynamic viscosity.
Poise is also unit of the dynamic viscosity. Keep in mind. And there is a correlation. Poise and Pascal second. Poise and Pascal second. What is that correlation? Means a unit conversion.
1 Poise equals to 1 by 10 Newton second per meter square.
Okay, 1 Poise is equal to 1 by 10 Newton second per meter square. In different form, 1 Poise is equal to 1 by 10 Pascal second. Am I right?
Yes, sir.
And again, we need to write the conversion if required or if asked in the question paper in the numerical format. Dyne. So what is the correlation? Dyne, gram, centimeter and second square.
1 dyne equals to 1 gram centimeter per second square.
Correct. 1 dyne is equal to 1 gram centimeter per second square. Okay. So what will be the unit of kinematic viscosity? We already discussed this part. What will be the unit of kinematic viscosity?
Meter square per second.
Meter square per second. Correct. Keep in mind, the unit of kinematic viscosity is meters square per second, and unit of dynamic viscosity is
Pascal second.
Pascal second. Correct. And one numerical we discuss, we solve in last lecture. Okay. So before taking the revision of that numerical, can you tell me, anyone, Stoke is a unit of which viscosity? Stoke.
Kinematic viscosity.
Kinematic viscosity.
Which one, Aniket? Aniket, dynamic or kinematic? Stoke.
Kinematic.
Yes. Stoke is a unit of dynamic viscosity, and Poise or dyne is a unit of dynamic viscosity. Keep in mind. And what is a conversion? 1 Stoke.
1 Stoke equals to 10 to the power minus 4 meters square per second.
Correct. 1 Stoke is equal to 10 to the power minus 4 meters square per second. This conversion is very, very important while solving the numerical. If the value given in Stoke, if value given in meter square per second, then there is no doubt, no utilization of the unit conversion. Okay. You simply write the value, whatever the value mentioned in the numerical. But if value given as a Stoke, then you need to convert using this unit conversion. 1 Stoke is equal to 10 to the power minus 4 meters square per second. And this numerical we already discussed. Determine the viscosity of liquid having kinematic viscosity 6 Stoke and specific gravity 1.9. Can anybody tell me, if the specific gravity is given, if the specific gravity of any liquid is given, then how we can calculate the density of that liquid? If the specific gravity of liquid is given, what will be the density of that liquid? How?
With the help of specific gravity formula, density equals to specific gravity into density of water.
Okay, but density of water is a fixed value.
Yes.
1000.
1000.
1000. If you take 1000, what will be the unit of density? If you take 1000 density of water, so what will be the density unit?
Kilogram per
kg.
meter cube.
Correct. Kg per meter cube. Kilogram per meter cube. Then, if the velocity distribution is given, if the velocity distribution is given, it means that there is a relation of u and y. U means what? Velocity, and y is a distance. If there is a velocity distribution is given in the numerical, and you have to find out the shear stress or viscosity. That viscosity, it may be dynamic or it may be kinematic. If the velocity distribution is given as equation form, in this equation form, where u is what? Velocity. And y is what? Y is distance. U is a velocity and y is a distance from the plate. Distance from the plate. The first step of any numerical, is which one?
Write given data.
First of all, you write the given data. So as far as this numerical is concerned, du by dy is a velocity distribution. Velocity distribution, or another alternative name for the velocity distribution is the velocity gradient. Velocity distribution or the velocity gradient. And velocity distribution or velocity gradient is equal to 2 by 3 minus, one mistake is happened in this numerical. Which one mistake? In the equation form. Y. Okay. 2 by 3 y minus y square. That is equation number 1. So dynamic viscosity is given as 8.63 poise. Dynamic viscosity is given as 8.63 poise. So instead of dynamic viscosity, suppose there is mentioned the viscosity of the fluid 8.63 Stoke. 8.63 Stoke means which viscosity?
Kinematic viscosity.
Kinematic viscosity. And if it is mentioned 8.63 poise means which viscosity?
Dynamic viscosity.
Dynamic. Why?
Because Stoke is a unit of kinematic viscosity and poise and dyne is a unit of dynamic viscosity.
Correct. So here in this equation, we need to find out the shear stress, and shear stress we can find out using the one law. That is which law? Newton's law of viscosity. That law is Newton's law of viscosity. And what is equation of Newton's law of viscosity?
Tau
What is
is equal
equation?
to mu into du by dy.
Yes, tau is equal to mu into du by dy. Here du by dy is a velocity distribution and it is found from the equation number 1. And mu is a dynamic viscosity and its value is given 8.63 poise. How will you convert 8.63 poise into Pascal second?
One by 10 into Pascal second.
1 by 10 into whatever the value is given in poise, means 8.63 into 1 by 10. That is Pascal second or Newton second per meter square. And then we can put the value of du by dy. By finding du by dy at y is equal to 0. Say from equation number 1. What is equation number 1? Du by dy is equal to 2 by 3 y minus y square, and put y is equal to 0 in this equation. So remaining term is 2 by 3. Okay. See here, 2 by 3 y minus y square. Here would be, you need to change the equation, that is a y square y and square 2 by 3 y minus y square. Okay, and we need to put y is equal to 0. If we put here y is equal to 0, what will be the value of du by dy?
2 by 3.
Okay. Before that, you say the equation, whatever the equation mentioned in the numerical itself, the equation is, you need to revise this numerical again. U is equal to 2 by 3 y minus y square. Okay, y minus y square. And you need to take the derivation of equation number 1. Take the derivation of equation number 1 with respect to y. With respect to y. So what will be the derivation of equation number y? Equation number 1. Take the derivative of equation 1. Take the derivative of equation number 1. Why we need to take the derivative of equation number 1? Can anybody guess it? See in the numerical, velocity distribution over the plate is given. U is equal to d 2 upon 3 y minus y square is a velocity and distance correlation. Velocity and distance correlation. But as far as Newton's law of viscosity, we need the equation du by dy. We need the term du by dy. So how to find the du by dy? Take the derivative of equation number 1 with respect to y. Is it understood? We required take the derivative of equation number 1 with respect to y because of in equation number 2 here mentioned du by dy. Is it understood? Hello?
Yes, sir.
Why we need to take the derivative of equation number 1 with respect to y? Tell me. Why we need to take the derivative of equation number 1 with respect to y?
सर न्यूटन्स लॉ ऑफ विस्कोसिटी नुसार आपल्याला du by dy पाहिजे ना म्हणून.
Okay. Okay. In equation number 2, we require du by dy and we have the equation of u. Therefore, we need to take the derivative of equation number 1. Derivative with respect to which term?
Y.
Derivative with respect to y term. So take the derivative of equation number 1 with respect to y. So this is equation number 1. And what will be the derivative of equation number 1? Can anybody guess it? Left hand side is du by dy. Is it correct? Left hand side. Derivative of u with respect to y. Derivative of u with respect to y. Du by dy. Derivative of u with respect to y means du by dy. Okay. And derivative of first term with respect to y. Derivative of first term with respect to y. What is derivative of first term with respect to y? 2 by 3 is a constant. 2 by 3 is a constant. And derivative of y with respect to y. Derivative of y with respect to y, it means
1.
1, or we can write dy by dy. Okay. Or we can write dy by dy. Similarly, derivative of y square is what?
2y.
2y. Yes, 2y into dy by dy. Okay. So the final derivative will be, what will be the final derivative of this term? We can simplify this equation. And if we simplify this equation, the term is remaining as a, which term is remaining? This du by dy get cancelled, and dy by dy, this term get cancelled. So remaining term is 2 by 3 minus 2y. Is it understood?
Yes, sir.
So du by dy is equal to 2 by 3 minus 2y. Is it understood this term? How this equation comes?
Yes, sir.
Lalit,
Yes, sir.
Sakshi, and Gay, is it understood? Aniket, Akshay,
Yes, sir.
is it understood?
Yes, sir.
Why here mention 2 by 3? Justify. Akshay, why here we need to write 2 by 3 only?
Y चे डेरिव्हेटिव्ह 1 झालं ना.
Derivative of y with respect to y is 1, correct? And y square is replaced by 2y. Why? Y square is replaced by 2y.
Y स्क्वेअरचं डिफरन्शिएशन 2y होतं.
Okay, derivative of y square is 2y with respect to y. So this is a derivative of u with respect to y. And this equation, from this equation, we need to find out du by dy at y is equal to 0. Okay. I will write in this different form like this. So y is equal to 0. Is it understood? Du by dy at y is equal to 0. Similarly, find du by dy at y is equal to 0.15. Du by dy at y is equal to 0 means we need to put y is equal to 0 in equation number 3. From which equation? Equation number 3. And similarly, at y is equal to 1.5, so 2 into 1.5. What will the value of du by dy? Is it correct? Value of y, du by dy at y is equal to 0, 2 by 3. Similarly, we need to find out y is equal to 0.15 in equation number 3. What will be value of du by dy? Is it 0.36 or a different value? We need to put 2 into 0.15.
Yes, sir. Correct value. 0.30.
0.36,
0.30.
0.30, not 36, 0.30. Okay. du by dy at y is equal to 15 means we need to put y is equal to 0.15 in equation number 3. So first term, see here, 2 by 3. This term we need to write as it is. I will need to some simplification here just for understanding purpose. Here y is equal to 0. So 2 by 3. Again, we need to write it here. Y is equal to 0. Yeah. So this is equal to into 0. So remaining term is, now it is more clear, more details. Is it understood? Is it now more clear? 2 by 3 minus 2 into 0, that is du by dy at y is equal to 0 is equal to 2 by 3. Similarly, we need to write y is equal to 0.15 in equation number 3. I will write this equation in very clear format. You can see here 2 by 3. Y we need to put y is equal to 0.15, 0.15, and you can simplify it and tell me what will be the value of. You can do the calculation. Tell me. Now it is more clear. Now it's more clear. Am I right? 2 by 3 minus 2, y is 0.15. What will be the value of du by dy at y is equal to 0.15? Tell me fastly. Lalit. Is it understood or not? Srushti, Baka.
Yes, sir.
What will be the value?
0.36.
Are you doing calculation or not? Aniket, Lalit. Okay.
Yes, sir.
du by dy at y is equal to 15, 0.15 is equal to 0.36. Is it? Now we need to find the shear stress. We need to find the shear stress at y is equal to 0. Okay. Which equation we need to consider to find out the shear stress? Equation number 2. Newton's law of viscosity. We need to put the value of du by dy in equation number 2. So this is equation number 2. And in this equation number 2, we need to put shear stress at y is equal to 0. Okay. So here you need to mention du by dy at y is equal to 0. See here, y is equal to 0. Shear stress at y is equal to 0. And then du by dy, we again put the value of this one. At y is equal to 0. Is this equation visible?
Yes, sir.
Tau at y is equal to 0 is equal to mu into du by dy at y is equal to 0. Is it? And we know the value of du by dy at y is equal to 0. What is value of du by dy at y is equal to 0? Tell me, value of du by dy at y is equal to 0. That value is 2 by 3. See, this value du by dy at y is equal to 0 is 2 by 3. We need to put that value du by dy at y is equal to 0 in this equation, and you can simplify it. That value will be tau at y is equal to 0. The value of shear stress at y is equal to 0, 0.5753 Newton per meter square. Newton per meter square. Is it understood?
Yes, sir.
Okay. Similarly, we need to put the value of du by dy at y is equal to 0.15. 0.15. So we get the value of shear stress at y is equal to 0.15. So we need to put it again 0.15 here at y is equal to 0.15. This is replaced by 0.15. And what will be the value of du by dy at 0.15? What is value of du by dy at y is equal to 0.15?
0.36.
Yes, 0.36. So we need to write here 0.36. Okay, and what is the value? This one. What is calculation? Aniket, Lalit. What will the calculation? Tell me. What is the calculation? Is it same result or different? 0.3105. Shear stress at y is equal to 0.15. Shrutika,
Yes, sir.
is it same value or different?
Yes, sir. Same value.
Lalit, what is your answer?
Sir, 0.3106.
Okay, no issue. At least 2 digits should be same. 2 digit after point, it should be same. At least. Aniket,
Same values.
okay. Now the next numerical. This numerical asked in question paper for I will show you the numerical in the question paper. See this numerical. How many marks for this numerical? How many marks for this numerical?
8 marks.
8 marks. The velocity distribution for the flow over the flat is given by u is equal to 1.5 y minus y square, where u is a point velocity in meter per second at a distance y meter above the plate. Determine the velocity gradient and shear stress at y is equal to 5 and y is equal to 10 centimeter. Assume dynamic viscosity 10 twice. Is this numerical, and whatever the numerical we solve, what is difference? What is difference between these two numerical?
No, sir, both are same.
Both numerical is same, only change is what? Value. Here y is equal to 5 and y is equal to 10. This is different. And value of dynamic viscosity is changed. Here 10 twice is mentioned. And this equation is a same equation. As far as this numerical we solve is a, see here, 2 by 3. Slight different. Okay, but Remaining part, procedure of the numerical is same, nothing any change. We solve that numerical. Okay, we solve the same numerical, whatever the mention in this question paper. Okay. This numerical. The velocity distribution for the flow over the plate is given by u is equal to 1.5 y minus y square, where u is a point velocity in meter per second at a distance y meter above the plate. Determine the velocity gradient and shear stress at y is equal to 5 and y is equal to 10 centimeter. Assume that dynamic viscosity has 10 points. This question for 8 marks in question paper. We solve this numerical. The numerical is very similar. We take the first step. What is the first step? Tell me. What is the first step of the numerical?
Write given database.
First of all, you need to write the given database. So tell me what will be the given database? In the numerical, what is the given database? See, this is a numerical and tell me the given database. What is equation? This equation you need to change 1.5 y minus y square. 1.5 y minus y square. This is equation number 1. What is the dynamic viscosity? We take the same numerical, just copy and paste, just change the value, whatever they mention in the numerical. This 8.63 is replaced by which value?
10.
10. Okay. This is replaced by 10. And what is conversion? What will be the conversion?
1 Newton second per meter square.
Yes. And this is replaced by 1 Newton second per meter square. Correct? And find the shear stress. This y is equal to 0 is replaced by
5
5, but unit is centimeter.
centimeter.
And again this y, next y is replaced by
10 centimeter.
10 centimeter. Centimeter is SI system. Centimeter, is it SI system or a CGS system?
CGS system.
CGS system. So we need
PGS
to,
system.
okay, we need to convert centimeter to meter. What is 5 centimeter to meter? 5 into 10 to the power minus 2. What will be the conversion? 5 centimeter to meter. 0.05 meter.
Yes.
And what is the conversion of 10 centimeter to meter?
0.1
0.1
meter. 1 meter.
meter. Is it understood? Then we know that the velocity, Newton's law of viscosity equation, Newton's law of viscosity equation. What is Newton's law of viscosity equation? Tau is equal to mu du by dy. We need to write the same equation. Tau is equal to mu into du by dy, where du by dy means velocity distribution. And then take the derivative of equation number 1. Take the derivative of equation number 1, and this is equation number 1. Take the derivative and tell me what will be the value. What will be the result after derivative?
1.5 minus 2y.
1.5 minus
2y.
Minus
2y.
2y.
Correct. 1.5 minus 2y. Is this understood? How will take the derivative?
Yes, sir.
Yes, sir.
I think this part is already you studied in which mathematics, 1 or 2? M1 or M2?
M1.
M1. Okay, we'll take the revision of that one. Again, from equation number 3, we need to find du by dy at y is equal to
0.05 meter.
0.05 meter. 0.05 meter. So you put the value and find out the value of du by dy at y is equal to 0.05 meter. Tell me, what is the calculation?
.56.
What is calculation? Tell me.
One point four.
1.4. Is it 1.4? How many students getting the same result? 1.4.
Yes,
I
sir.
get, sir.
Okay.
I also get.
We need to find at y is equal to 0.1 meter. At y is equal to 0.1 meter. See here, at y is equal to 0.1 meter. Before that, you see the numerical, what we ask in the numerical. What is asked? Determine the velocity gradient and shear stress. Velocity gradient means velocity gradient means what?
du by dy.
Du by dy.
Du by dy. Okay. So we already find du by dy at y is equal to 5 and y is equal to 10 centimeter. Okay. We just put the values and find out the value of du by dy, velocity gradient, and we already calculated the velocity gradient. That is, we can mention answer. We can write it here. This is one of the answer. Okay, and this is another one. What is the unit of this du by dy? We need to write the unit
Pascal second.
du by dy. What is unit of du, change in velocity?
Meter second.
Meter second or meter per second?
Sorry, meter per second.
Meter per second. And again, what is the unit of dy?
Meter.
Meter. So what will be the combined unit?
Meter square per second.
Meter per second. And this one is meter. What will the combined unit? What is the combined unit? Tell me. Meter per second divided by meter
Second.
per second. Is it? Unit is? Is it understood? How it's per second? Meter per second and divided by meter. So meter get cancelled. That is per second. Unit of du by dy is per second. We need to write the unit because we have to find out the value, velocity gradient. That's why we need to put the unit also. If you forget to put the unit, your marks, at least 1 mark will be reduced. Okay, is it understood how its unit is per second?
Yes, sir.
Yes, sir.
Okay, then we again find the shear stress. Again, find the value of shear stress. So we have the equation second, Newton's law of viscosity. This is equation number second, Newton's law of viscosity. We just put, so we get the value of tau, two values of tau. We get the two values of tau. One is for y is equal to 0.05. Similar, we put 0.05. So what will be the value of du by dy at 0.05?
1.4.
This viscosity is replaced by 1, and this 2 by 3 is replaced by 1.4. So what is the calculation? What is calculation? Tell me. 0.05. What is calculation of this one? 1.4. Same calculation. 1.14 meter per Newton per meter square. This is one of the answer. Okay, shear stress at 0.05 meter. Similarly, we need to find the value of tau at 0.1 meter. 0.1 meter. So what will be the value of 0.1 meter?
1.3.
So this 0.836 is replaced by 1, and this 0.36 is replaced by which value? 0.36 is replaced by
1.3.
1.36. 0.36. No?
नाही ना सर ते व्हॅल्यू काढली नाही सर
Okay. This is remaining. What is value of this one? What is calculation of this one?
1.3 आलाय सर ओव्हरऑल
1.3.
1.3.
Okay. Just wait for 1 minute. 2 by 3 minus 2 into 0.15.
सर y.1 आहे ना.
Okay, this is replaced by, still calculation is missing. 1.5 minus 2y. This is 1.5 and then 2y, correct? This is replaced by 1.5 and then 2 minus 2y. 1.5 minus 2 into 0.15. What is calculation? 1.2. Lalit?
1.3 आलाय सर.
See, 1.5 minus 2y is correct. 1.5 minus 2y. See, du by 1.5 minus 2y, and what is value of y?
Point one in
Yes sir,
y.
1.2.
0.1. Okay. This is 0.1 and
1.3 second in sir.
1.3 second. Lalit, you do the calculation carefully. One mistake is happening. This 0.1 we need to put, but before that we put 0.15, but not required. It required 0.1. So y is 1.3. Okay. So we need to put here is a 1.3. So what is the calculation?
1.3.
Correct. 1.3. Unit is what is unit?
Pascal second.
Pascal second. Pascal
Second.
second is a unit of the viscosity.
Sorry, sir. Newton per meter square.
Newton per meter square. Correct. Newton per meter square is a unit of the shear stress. Unit of shear stress. What is unit of shear stress? Tell me.
Newton per meter square.
Newton per meter square. Correct. What is a unit of dynamic viscosity? What is unit of dynamic viscosity?
Pascal second.
Pascal second. Correct. What is a unit of velocity gradient?
Per second.
Per second. Keep in mind. Any doubt in this numerical? Whatever the numerical we discuss? Any doubt?
No,
This
sir.
numerical is very, very important.
Sir.
And tell me, what is your doubt? Siddhant? Any doubt from your side?
No, sir.
Okay. This type of numerical, if asked in the question paper, what will be the weightage for this type of numerical?
8 marks.
8 marks.
8 marks.
8 marks. It's a very simple numerical, but you solve the numerical carefully. Steps is very simple. Okay. Which equation we require? Only 2 equation. Which equation we require? Only 2 equation. Which 2 equation? One is a velocity gradient and another is a Newton's law of viscosity.
Newton's law of viscosity.
And velocity gradient. How we can find out the velocity gradient? From which equation? Velocity gradient we can find out from which equation? Velocity equation. The correlation between velocity and distance. Correlation between velocity and distance. From that we can find out the velocity gradient. Understood?